This is a story about Ame, Arisha and Auni. Ame, Arisha and Auni has been planning to go to a museum for an exhibition this Saturday. On the Saturday morning, Ame had forgotten that the water supply has been cut off due to pollution. However, he found that one of the pipes still supply water at a slow rate. It was 9 a.m. and he needs to fill up at least 3/4 of the bucket before 1 p.m. He called his friends for help to figure out whether he has enough time to collect enough water or not. How will the story goes? Let's find out. Oh no, where am I supposed to get water? I need to get ready on time. They will surely kill me if I'm late. Wait, how about that pipe? What am I supposed to do? I should call Auni. Hello, Auni.
Hello, Ame.
Auni, I have a huge problem.
What is it?
I forgot that the water supply has been cut off for today.
I thought I reminded you already. Hey.
I am so sorry. One of the pipes still supply water, but at a very slow rate.
Can you measure the rate of flow of the water? Just take a measuring instrument like a measuring cup and measure how many milliliter of water you can collect in 1 minute.
Oh, okay. Done. Now what?
Do you have a bucket? If so, do you know the volume of it?
Of course I have a bucket, but I don't really know the volume of it.
Oh no. Then how?
Don't worry, I have a measuring tape and I know how to calculate the volume.
How?
To measure the volume of the bucket, we need to find the upper and lower radius of the bucket as well as its height.
Wait, why do we need to do so? I thought a bucket is cylindrical in shape.
The water bucket is modeled by a frustum of a cone, so it is not a perfect cylinder. The volume of the standard water bucket is the volume of the larger cone minus the volume of the lower cone.
I see.
Try measure the volume of the bucket together.
So, from the findings, we found that the rate of flow of water is 20 milliliter per minute, and the general formula for the volume of the bucket is... So now what?
How to measure the volume of bucket? First of all, we need to know the volume of big cone and also the volume of small cone. We have to use the formula 1/3 pi r square h, and before that, we also need to know the radius of the big cone, which is 25.6 cm divided into 2, and also the radius of the small cone is 23 cm and divided into 2. And we need to substitute the information that we got into this formula and we will get the answer here.
Hi, so
I am going to proceed our next calculations. So from the answer that we got before, which is 1 over 3 pi multiplied with 31.59a plus 1 over 3 pi multiplied with 163.84h. So from the answer that we got here, we are going to use the one that I have circled in purple because the formula is referred to the bucket that we are using. So the formula of the bucket, which is V equals to 163.84 pi h over 3, we are going to differentiate it to dV over dH. So we got 163.84 pi over 3. So we already have our dV over dH, and we already have our dV over dt that have been given by Ame. So we are going to find dH over dt. So the answer that we got from the calculations, by putting the real value of the dH over dV and dV over dt, so we could get 0.1166 cm over minute, which is here. So after we got our dH over dt, we need to remember that Ame have stated that he needs to fill in 3 over 4 from the height of the bucket. So we need to multiply 3 over 4 with 27, which is the real height of the bucket. So we could get 20 over 20.25 cm. So now the last calculations that we need to do is to find how many hours does Ame need to fill in the bucket. So we need to divide 20 over 25 cm with dH over dt that we got before, which is 0.1166 cm over minute, and we could get 2.8945, which is equals to 2 hours and 53 minutes. So that is the answer.
In a nutshell, with the water flow rate of 20 milliliter per minute, it will take Ame around 2 hours and 53 minutes to fill up 3/4 of his bucket. So he needs to start collecting at most around 10 AM.